All right, so this is chapter 10, problem number 38, which is a kind of a combo problem between momentum and energy. So it reads, ball 1 has a mass of 100 grams and traveling at 10 meters per second. It collides head-on with ball 2, which has a mass of 300 grams and is initially at rest. What are the final velocities of each ball if the collision is A, perfectly elastic, and B, perfectly inelastic? So writing down the information that we have, we know that ball 1 has a mass of 0.1 kilograms. Ball 2 has a mass of 0.3 kilograms. The initial speed of ball 1 is 10 meters per second, and the initial speed of ball 2 is 0. And they would like to know what are the final speeds of both balls after they collide. So in part A, they want to know what happens, what are the speeds if it is perfectly elastic. What you can do is you can go through and you can combine conservation of momentum with conservation of energy, right? And you would have an equation that is m1 v1I plus m2 v2I equals m1 v1F plus m2 v2F, and then you would have 1/2 m v sub 1 I squared plus 1/2 m v sub 2I squared equals 1/2 m v sub 1 f squared plus 1/2 m v 2 sub f squared, right? And this would be your momentum equation, and this would be your energy equation. And you could solve for them, and you would get a couple equations that the book gives you on page 311 that says V1F is going to be equal to M1 minus M2 divided by M2 plus M1 times V1I. All right, and then they give you the second equation to find V2F is equal to 2m1 divided by m1 plus m2 v1I. So now, in a quick and dirty, if you want to, you can plug it all up into these equations right here. You'd have to do some work to get some algebra. Even the book mentions that it's kind of a lengthy algebraic exercise, and you'd come out with these two equations. So just plugging in what we have 0.1 minus 0.3 divided by 0.1 plus 0.3, and then times 10. And when you get that, you find that V1F is equal to -5 meters per second. Now plugging in what we have here, we have 2, M1 is 0.1, and then 0.1 plus 0.3, and then times 10, and you find that V2F is, equal to 5 meters per second. Okay. Now for part B, they want to know what happens if it is perfectly inelastic. So we're left with, starting with two objects, right, that each have their own momentum. So we have m1 v1 initial plus m2 v2 initial, and if it's inelastic, they're going to hit and stick. So there's only essentially one object that has a mass that is equal to the sum of the two of them together. Two objects that are hitting and sticking together. Now, the second object right here, mass 2, it has an initial speed of 0. So that whole term becomes 0. And now it's just quick plugging in of 0.1 times 10 equals 0.1 plus 0.3, and then times V sub f. Here we then have 1 equals 0.4 V sub f. So the final speed is 4 meters per per second. So really the big part of this problem is that part A, in going through and combining conservation of momentum with conservation of energy to get these two relationships right here, and then solving for the final speeds of the two different objects. So that is Chapter 10, problem number 38.